Okay, so this is the 3.3 video, which is just the converses of all the 3.2. So there's actually no new information in here. We're just going to do everything backwards. So remember from converse from chapter 2 was if you had a conditional statement P to Q, then the converse would be Q to P, where whatever if the sun is shining, then I'm happy. You would flip that and say, if I'm happy, then the sun is shining. So we're going to take all those postulates and theorems and corollaries that you learned in the last section, and we're going to flip them. So all of those in the last section said, if the lines are parallel, then corresponding angles are congruent. So we're going to say that backwards now. We're going to say, hey, these angles are congruent. That must mean the lines are parallel. So same stuff we did yesterday, exactly backwards. So how would you find the converse of a theorem? Exactly the same way you would find a converse of a statement. You flip it, the hypothesis and the conclusion, you flip their places. So same way. Okay, so you've got your vocabulary grid out so you can see the converses for corresponding angles postulate, alternate interior, exterior, and same side interior. So we're going to do the opposite of everything we did yesterday. We're going to be, instead of given the lines are parallel, tell me about the angles, we're going to do exactly backwards. So on this first one we have, given that measure of angle 4 is 2x plus 10 and 8 is 3x minus 55, x is 65, prove that the lines are parallel. Okay, so let's start where we always start with our given. Measure of angle 4 is 2x plus 10 degrees. Measure of angle 8 is 3x minus 55 degrees. And x is equal to 65. That was given. We are trying to prove, if you scoot way down, we're trying to prove that L is parallel to M. Okay, so we can look at our picture here and we can tell 4 and 8. So what kind of angles are 4 and 8? Well, they're corresponding because 4 is in the bottom right and so is 8 in the bottom right. So I know from yesterday that corresponding angles should be congruent if the lines are parallel. So I'm going to see if that happens here today. So the next thing I want to do is I want to see what happens when x is 65. So I am going to substitute x on in there. So I'm going to have measure of angle 4 is 2 times 65 plus 10. And measure of angle 8 is 3 times 65 minus 55. Okay, so I just substituted x in, and now I want to see what happens. So I'm actually going to simplify and figure it out. Remember, you're not multiplying because you're not doing it to each side of the equation. You're just doing it to one side of the equation. So go ahead and tappy that in your calculator. For measure of angle 4, you get, I don't think I did that right. I don't think I tapped right. Hold on, let me try again. 2 times 65 plus 10. I should probably already know that. It is 140 degrees. Measure of angle 8, let's do that the same way. So let me put this in my calculator and see. 65 times 3 plus... It would help if I would bring my real school calculator home instead of this little crappy one. Minus 55, 140. Good, so they both equal 140 degrees, which is what I was hoping. Okay, so here's where we get into the more proof stuff. 4 is 140 and 8 is 140. So what does that mean about 4 and 8? Well, it means that they are equal to each other. Now, how do I know that? Two ways. You can either use substitution and you can pretend you were going to say 4 equals 140 but you substituted 8 in, or you can use transitive. If A equals B and B equals C, then that must mean A equals C. So if you have an equal sign, you can use either substitution or transitive. Where you got in trouble on some of you on your test is transitive only works with congruent. It doesn't work with, substitution only works with equal, it doesn't work with congruent. But if you have equal, you can choose your favorite. Do I want to call it substitution? Do I want to call it transitive? It doesn't matter if you have an equal sign. They say the same thing. So I'm going to call this transitive property. Then, if I know they're equal, I know that they're congruent. And anytime you go back and forth between equal and congruent, what is that? Definition of congruency. You can call it congruent angles or just definition of congruency, I don't mind. Then the actual stuff we're learning today, if these angles are corresponding and they happen to be congruent, well, what must that mean? That must mean those lines were parallel after all, and that is the converse of the corresponding angles postulate. Now, how you can tell if you want the regular or the converse is look on your chart under conclusion which one matches. So in this one, so you've got your little chart going here. On this one, the conclusion is whatever it is. M is parallel to N, and that's your conclusion, so that must mean that you want to use the converse. So if you end up with lines are parallel, you've done the converse. If you end up with, hey, here's the angles, you've done the regular. So ending with the angles, therefore I must be talking about the converse. Okay, very good. Let's flip over to the next. This one is the same kind of process, only I don't have to do a whole proof. I can just explain it with the one justification. So 2 is congruent to 6. If angle 2 is congruent to angle 6, that must mean R is parallel to S. Which property is that? Well, what kind of angles are 2 and 6? 2 and 6 are alternate interior angles theorem. And if I'm proving lines are parallel, I'm going backwards, so that's going to be the converse of the alternate interior angles theorem. There's not even any work to be done on that problem. The angles are congruent, therefore the lines are parallel. You're going backwards, so it's converse. Good. Okay, let's look at this one where we actually have to fill in. So 6 and 7, what kind of angles are 6 and 7? 6 and 7 are same side interior angles. We're working this problem backwards because they gave me the angles. They're asking me to talk about the lines. So I am going to use the converse when I'm all done. Well, let's make sure it actually works though. So let's go ahead. The measures of same side interiors are the only ones that should be supplementary. So I'm going to try that one out. Make sure you make them supplementary. If you make them equal, it won't work and you'll wonder why. Okay, so I'm going to add them up and set them equal to 180. Now I'm going to go ahead and plug in 10. Okay, you can go through and put that in your calculator. 6 times 10 plus 18, 9 times 10 plus 12. You can actually do it all in one shot if you want to. And sure enough, 180 is equal to 180. So if these add up to 180, that must mean that the lines are parallel. Okay, so therefore, we should probably write that. R is parallel to S. We can write it over here. R is parallel to S because of the converse of the alternate interior angles theorem. R is parallel to S because of the converse of the same side interior angles theorem. Good, so if you're ending with lines are parallel, you must be using the converse. Okay, look at example 3. Go ahead and fill in 1, 2, and 3, L and M here. This is going to be R and P here. I couldn't get that to fit on that diagram. So here we go. Given that L is already parallel to M, so I've marked that on my picture, and 1 is congruent to 3. Prove that R must be parallel to P. So let's start. L is parallel to M. R is parallel to P. I'm not sure if I'm going to use these givens together or if I'm going to use them separately until I get started. So I'm going to hold off on putting 1 is congruent to 3 in there. If it turns out that I don't have space for it separately, I'll go back and squeeze it in. If I need it for a different step, then I'll use it here in a second. Okay, so if L is parallel to M, then let's ignore this all down here, and I can treat this just like a problem that I would have earlier, like yesterday or even day before. If L is parallel to M, what kind of angles are angle 1 and angle 2? Well, angle 1 is top left, angle 2 is top left, so those must be corresponding. So even without knowing anything else about the problem, without talking about P or angle 3 or anything, I know 1 is congruent to 2 by the corresponding angles postulate. Now, how come that's not the converse? Well, it's not the converse because I started with lines and I'm ending with angles. So that's the normal way. So I don't use the converse there, I use the normal one. Now, I'm kind of stuck here. So I'm probably going to go back and use this other given as a separate sentence. Let's see. Yep, angle 1 is congruent to angle 3 by the given. Now, if you were doing this by yourself and you put 1 is congruent to 3 over here and you just went straight from step 2 to step 4 and you just had a 4-step problem, that would be no problem at all. But because I filled in the blanks for you, we kind of have to follow along. Okay, so now look what we've got here. 1 is congruent to both 2 and 3. So what does the transitive property says? It says, well, if A is congruent to B and B is congruent to C, then I don't need 1 anymore. I can go directly from angle 2 is congruent to angle 3. Angle 2 is congruent to angle 3. Everybody see what I did there? Okay, so now I'm done with angle 1, so I can just look at this picture this way. So now M becomes my transversal and R and P become the lines that I want to talk about. So looking at angle 2 and angle 3, I know that they're congruent because I just figured that out. Well, what kind of angles are angle 2 and angle 3? They are alternate exterior. So if they're congruent and they're alternate exterior, what does that mean? Well, it must mean R and P are parallel. And this way, we're going backwards. I give you angles, you give me lines, so I'm going backwards. So that's converse. What kind of angles are they? They're alternate exterior angles. Good, so reread this proof from top to bottom. You have to look at it 2 different ways. First, you ignore P and do corresponding angles postulate normal. Then you ignore L and you do alternate exterior, you do the converse. So that's a good problem because it's got kind of everything in one. Okay, last one here. During a race, all the members of a rowing team should be keeping the oars parallel on each side. If measure of angle 1 is 3x plus 13, measure of angle 2 is 5x minus 5, and x is equal to 9, show that the oars are parallel. Okay, you could probably do this problem by yourself by now, so if you want to pause and do it by yourself, then that's probably a good idea. So let's go ahead. They gave me x is equal to 9, so what, if you're looking, it's hard to see on this one, but the boat is actually the transversal, and the oars are the lines going through there. So if you'll draw over that, then it becomes a little bit more clear that you've got, hopefully, parallel lines cut by a transversal. So, what kind of angles are angle 1 and angle 2? Well, this one is bottom right. This one is bottom right. So I'm hoping that these are corresponding angles postulate. I'm proving that lines are parallel, so I'm going backwards, so that would be converse of the corresponding angles postulate. Now, let's see if it works out. So, corresponding angles I'm hoping are going to be congruent, so let's see, 3 times 9 plus 13. Okay, so that would be 27 plus 13, that would be 40. And then here, 5 times 9 minus 5, that would be 45 minus 5 is 40. Well, sure enough, angle 1 is equal to angle 3, which means that they're congruent, which means that the oars are parallel by the converse of the corresponding, oars are parallel by the converse of the corresponding angles postulate. Okay, so it's really telling me show, so I have to show my work. It's not enough for me just to plot down, yep, they work. I need to show them when I plug it in. I need to show them, hey, that means they're equal. Then the postulate is based off of congruent, not based off of equal. So go ahead and switch it on over and then tell me why. They're corresponding angles, so I use the converse of the corresponding angles postulate. Okay, very good. See you all tomorrow.